In this video, I'm going to show you how to accept payments in Bitcoin using the Coinbase API, and it'll be all be done in Go to interact with their REST API. This is a step-by-step process. I also have it done in snippets, and I'll point you in that direction if you're interested in just copy pasting it. This is both in written format and in video format. If you're only interested in grabbing this small little snippet of code that you need to actually do this, on my website we have two versions of this same lesson. One is a simple snippet, and the other one is all steps. The snippet-based one is here on my screen. You can just set it to be snippet, or you can go to the URL. I've put it in the description. What happens is essentially the general flow of the whole process is very, very simple. You want to create a unique address to tell someone to send money to Bitcoin to. You then want to check that address for transactions. That's the whole flow, and if the transactions are there, then they've paid. And so here's all the code that you need to create an address, and here's all the code you need to check for the listed transactions. It's all fairly simple. If you're not interested in that and you want a full walkthrough, that's where this other URL comes in. So all steps, again, it's in the description. Please take a look. We're going to do more of an in-depth walkthrough where I'm going to provide you some Go boilerplate code. We're going to just get that up and running. It comes with your like handlers, services, repositories. For this one, we're actually going to follow a little bit of a different approach. It's going to be someone going through an e-commerce store checkout. I have this diagram here, and I created it just because I just want to give you a little bit of a visual. So on the top, your user's computer represents someone on your website. They would be during their e-commerce store checkout, they'd be adding products to their cart. They then hit, I'm ready to check out, and you throw them into the checkout process. You then move them, they begin to fill in all their information, and then it's time to send a payment. So in this case, you would present them with a new address to send Bitcoin to, and then you'd wait till the transaction completed and the money has shown up, and then you move them to the completed stage. The gray arrows kind of represent that flow. The red arrows in this case represent the API calls that we're going to be doing. So we're going to be creating 3 endpoints. The first one is create order, which represents what products they're buying, the amount that we're charging them, and there's going to be the idea of status on that one. So they hit start the checkout process, and we create the order. Next, in the background, we're going to be updating that order, waiting for those listed transactions to come in. So that's saying create the address, list out the transactions, and then the last endpoint actually is a little bit different. This just provides our front end with a little bit of feedback during the checkout process. What's the order status? Have they completed it? So that we can move them through. And so that's where the last endpoint comes in. We'll be building all 3 of these endpoints. And you may be asking why this video. So I actually want to dig into this a little bit. I started actually writing this whole thing out in May of 2020. It's currently January 2nd, 2021. Bitcoin's at an all-time high. That wasn't my intention. Essentially in May, I was kind of sitting there wondering if I was going to, as a developer, everything's fairly, as a Canadian as well, everything's fairly US-centric on the internet. At least that's my opinion. And I want to know, is there a replacement for the US dollar? US dollar is kind of a standard. From what I see, nothing's often billed in Canadian dollars. And often, like for example, AWS, I get hit with a transaction fee every time I get billed. So I began to dig into this, trying to understand how this could potentially be used, and I also wanted to just kind of explore the Coinbase API to understand how to integrate with it, and so that's why I created this video. And anyways, yeah, so it's 8 months in the making, I guess, between writing the article and making it. So there might be a few changes, but nothing should be super different. Some prerequisites for this video. To start off with, I'm using a Mac computer. You don't have to use a Mac. I'm just telling you so that all my commands are going to be fairly Unix based and all kind of like related. I'll be operating on my Mac OS. Second would be Go. I'm using Go 1.14. That's for my tutorial. The current version I'm using. You don't necessarily have to use this version, but if too many things change, you'll understand why. Third, we're going to be using MongoDB as a data store. The boilerplate code we use connects to Mongo over no SSL and no username or password. This isn't a requirement, but if you're planning to use a username and password, you're gonna have to do some sort of tweaks to the connection string. That being said, if you're going to production, don't use no SSL and don't use no username and password. Please use both. But this is all for local development right now. Lastly, we're going to be using the Coinbase API. It's a RESTful API. I'm assuming you have a basic understanding of how RESTful APIs work, making HTTP calls. It's fairly simple. It's one poster call to create an address, and it's one get request to retrieve the transactions. So hopefully it's not overly complicated. It won't be, I guess the last part is, I won't be going over syntax for Go, so hopefully you have a basic understanding of how Go syntax works. I won't be covering that one. Looking back at the actual written tutorial here, so again, all steps should be in the title, it should be set to all steps. We're using Coinbase. Reason for using Coinbase, there's nothing in particular. I simply started using it and I had a great experience. It's fairly popular. They have a well-documented API, so why not use it? One request is if you don't have a Coinbase account, actually click the link here. It's a referral link. It gives me some free Bitcoin if you sign up. It's no charge to you. It just helps support the channel here. And we're going to be using the Coinbase developer API here. So we're going to be going through their developer docs. You'll have to have an account so we can create an API key, and I'll walk you through the steps for creating an API key in a bit. Let's dive into some code now. So we're going to be using this boilerplate code. I'm going to link out to it. The reason why for the specific commit is just in case I've modified it too much. I'm just going to go back to the code here, and I'm going to go into we could use the one that I referenced, which is actually the first commit. I'm just going to go to version 1.0.2. I know I have a bunch of fixes that I want to put in for 0.3, but this is the one I'm going to use. So for this, I'm going to hit download zip. If you're creating a project, feel free to fork this. If you're using this, feel free to start. It helps me just understand people are using it. Unzip the file, and I'm just going to, so I've unzipped on my left here. I create a new folder on my desktop. I'm just going to copy and paste all of the files in there, and we have a starting point. I'm going to close that. Open it up in an editor. I'm going to walk you through some of the code just to get you a little bit familiar with it. Everything is going to be unreferenced to the existing code base that we have, other than the database connection. That's the one that's going to really matter. I'm going to use GoLang. I just enjoy it. So open up the project. Perfect, and open project, desktop, and I'm just going to open the project here. Okay, so the project's all open. I'm going to just briefly explain it. In the DB file, you have the connection to the Mongo database. You can see my connection string right there. Change that if you need to. You get main.go here, which has a whole bunch of code for the boilerplate purposes, but we're not going to use any of it. What we really care about is this DB connection, and then we'll kind of create a brand new repository, create a brand new service, and a brand new handler. Well, then we're going to add a few new endpoints here. So I'm just going to actually follow this pretty closely so that you can use both of them. So first we're going to be creating a this line here, which adds the database. So scrolling back up here, we just want to add a new orders repository. We're going to be doing the same thing with service. And you can just you need to copy it from the tutorial here. Sorry, I'm just going to do this. And the last thing is the same with the handlers. a little context, I just copy and pasted 3 lines there, didn't really explain them. So the repositories layer is our data access layer. It acts as how we interact with the database. It's the last layer before we actually make database call. Is where we make the database calls. Service is where our business logic lives. So this will be where, for our orders example here, let's say the create order, we want to create the order. We want to create the order and save it in the database. So in that case, we call the repository layer. We want to then call the Coinbase API to create a new address. Okay, so I guess that kind of explains it poorly, but I don't know if we're going to create the address first, then save the new order, or save the new order, create the address, and then update the order. Either one, essentially it all happens in the service layer. Lastly, we have the handlers layer, which is essentially it's going to take a bunch of HTTP calls. So in this case, like our post to create the order, it'll take the request body and then map it into a Go struct. We then take that Go struct and pass it into the service layer. If an error comes back, we then, if it's a server error, for example, we want to bubble up a proper service internal server error prompt and things like that. The last thing we have to add here is our actual endpoints. So as mentioned, we're going to have 3. Again, I'm working off the written documentation just because to save myself on typing, but you don't have to. I'm going to copy what our endpoints are going to be. So in this case, we're going to have 3 of them. It will be the /orders will be the parent red group, and for submitting an order, it'll be just a slash. For getting an order, it'll be a slash and then the ID, and the last one will be /sync, which will sync all orders. So with that, we're gonna just copy and paste from the tutorial here. One's actually a mistake and I have to fix it. I just discovered, but that's fine. So we just need to add the ID there. So in this case, it'd be /orders, and then with the slash on the end, that's how we submit it. So the request body would contain all the information we need for submitting the order. The next one would be the get, which is /ID, which specifies a specific order. And the third one is a post, which just does a sync. So let's add our handler methods, because all 3 of these do not exist. So with that, we're going to start with our handlers. And so we're going to add new file, Go file, plus orders handler.go. In terms of content, I can tell you it's going to be very similar to, pick another one here. You can copy paste it over from here, or you can copy paste it from the actual tutorial. So it'd be the orders handler, and our service is not going to be the car service, it's going to be the order service. That doesn't exist, which is fine. We're not going to be creating that car handler, we're going to be creating the orders handler. Update this one. And we can actually, if we use uppercase here, we can just cut the corner and shorthanded. And lastly, we're going to be returning an instance of orders handlers. So I should mention that with the S. Orders service does not exist, so that's the next one we're going to create. But this should actually resolve this one, yeah. So it'll resolve that issue here. Next, we're going to create the orders service. So in the services, we're going to go new orders service.go. Again, I'm just going to copy the cars service. You can also copy right off the written documentation. It's just for speed usually. So order service, we'll create a new order service, create a new instance of order service. So we don't need the user repository or the cars repository. What we actually need is the order repository. And I'm going to use it capitalized here, which kind of lets me save typing. Do this. I know I'm moving a little fast. Again, that doesn't exist, so in my editor it will stay not working for now. But this should resolve the next line. And the last one we're going to create is the repository orders repository. So we're going to create orders repository.go. Probably look very similar to the cars one as well. This is kind of why I created the car one, so that we can just copy paste it from there. So it does the same thing. It takes the database, an instance of the database, a reference to the data, or pointer to the database. I'm calling this orders with an S, so I should keep it consistent. And what I'm returning is not the cars repository, and I can just do this actually, and it knows what I'm referring to. So we should be all set up there. Main.go should resolve that last issue, but it's still failing on our 3 submit order, get order, and order handlers. This time I'm actually going to reference the document, the written tutorial, just to save on typing. I'm going to still step through all of it. So we've just set up all of this. What we next need to do is this whole submit function here. So I'm going to create our 3 files, 3 handler methods here. So submit order, get order, and sync order. So open up orders handler. And I'm just going to paste that in. Let me just explain all of this. Here's submit order. It actually takes a request body. So this is a post request. So imagine it takes a JSON, and it's going to be the style new order. We'll create that in a second. What it's going to do is it's going to bind that to the JSON. So if it's a proper format, so we ask for X and we get X, it works. Otherwise it throws an error. We do validation. This uses the Go tags for validation. Then we simply just call the orders service, which also has a submit order, but now it's accepting a proper Go struct, and we know that data has been validated, and when we pass it into the service, we can confirm that it works. What it will return is the address. So this is our new Bitcoin address. It will be a string. It will return the price, so the total price. So it will calculate up, all these items, and it'll make more sense in a second when I show you new order. It'll pass you back the order ID. So this is what it's being saved as on the within the Mongo database. And lastly, it'll pass back an error if anything has gone wrong. If you look at line 36 there, you can see our JSON message here. Order submitted, here's the address, here's the total price, and here's the order ID. Next, and so this is going to be read for a little bit until we actually do the order service, and we will, but we'll just keep moving forward. Actually, I take that back. We're going to do the models, just so you can see the contents of that. So we're going to add one new model. So under models, we're going to add something called orders.go. And we're going to head back to our document here and our models.go. Let me just find it here. Yeah, so here's 3 of them. Okay, so here are our initial ones. So our new orders will be a list of items, and an order item is the name and the price. So that should resolve that. Hence why we're returning total price. Next on the list is get order. So we grab the ID. So I must just switch back over to my main.go. You can see the ID here. That's where, here. So that's where this ID comes from. Sorry about the jumping. We then just pass that order ID into the get order. Fairly simple. If you haven't noticed, we're not doing any sort of validation to confirm that the same person is making these calls. So technically, there's no proper authentication around this. We're assuming that someone is checking out of the process, and unless they guess the order ID, it's not really protected, which is fine. So the order service here, and what we're returning is the entire order. The last one here is the sync order. Sync order, we added the body, the model there too. It's the order ID, so it's for syncing a single order. In this case, it'd be just let's say you'd have a cron job, you're hitting post requests. The reason for doing the passing the ID in there is hypothetically you could set up your front end to also make those post requests a little less reliable, but this is more for just showing how this all works. So you grab you map your request body to your actual struct, you do the validation, and then you pass it into the service. It doesn't return anything other than a 200 if it's in the message, order synced if it's working. It's fairly straightforward. We're next going to add the order service so that we get a few better situations here. If we just quickly look at the actual written documentation, we actually switch over to the repository. We can actually do that one. So the repository, we're going to start with the create address function. The create address function is calling the Coinbase API. So if we just open up the Coinbase docs here. So you would pass in, there's a few things, your account ID and then this string. I'd love to tell you that this string is just simply your API key. It's not. I've actually found the auth process for Coinbase to be quite a process, which is fine. I mean, we are dealing with money. Just that's what made this a little bit more tricky working with this API key. So you have to pass in your API key. You have to generate a signature. You have to pass in the timestamp. Then you have to build this SHA-256 HMAC using all these attributes. So timestamp, method, request path, and body, and to generate this like signature. Yeah, it was just an interesting process, like because you start to deal with things like UTC time, like they're expecting UTC time, and you might be working like you have to make sure you actually switch your time zones over and things like that. Sometimes systems just do it automatically, which all makes sense. But it was just a little bit more tricky. So I'll show you how to do all that. The code's a little bit written, so it shouldn't be overly challenging. Let me just return to create here. Here down create, so we have these three things, and then we provide a name for the new address. Great reference would be like just your order ID. You're creating a new ID anyways, so great way to use it. And what that would return back, that API call, would be your new address and a little bit more information about it, but for the most part, the new address is all you care about. That gets attached to the order. After that, we would save the order to, save that information to the order, and we'd save the order to the database. We'll do those steps after though. So we'll start with this create address. We're gonna put it in the orders repository. I did this because it's technically not a service, there's no business logic here. You could create a Coinbase package if you wanted to. For this project, it's really small, so I'm just going to throw it right in the order service. So I'm just going to actually copy all this code, and I'll walk you through and explain some of it. So orders repository. It's going to do a whole bunch of importing. I realize that I don't haven't explained get account ID. Where's the get account ID? I'm just gonna do this. I just did a control find there. Essentially what we're going to do is we're going to pass in the Coinbase account ID, the Coinbase API key, and the Coinbase secret, all through environment variables, just to keep them a little more hidden. So yeah, and so we'll just pull them out of our environment variables. What's happening here is our create address. So we grab the account ID and we build that request body. So we take basically our map here, which is in Go, and we map it to this request body. If that fails, we just throw the error. We return an empty string and an error. The base URL is the api.coinbase. The request path is all here. We build that. The reason why this is a variable is because, as you saw with the signature, we're going to have to use it in a second to actually sign, create a signature, build the URL for the request. We then build the new post request. So let me just hope that resolved itself somehow. I'll have to look into that. Yeah, and so then we build the new post request with the request body. We create the request timestamp. It's in UTC in the Unix format. I can show you that in a second actually. If I look at the Coinbase auth, they had a time. Hold on, let me just find that. They had a time which shows you the correct format for time. Oh yeah, epoch time, Unix here. So it's in number of seconds. So it looks like this. Anyways, back to this. So we convert our time, the current moment, into UTC, and then we convert it to Unix so that it's this, it's in like seconds in that epoch time. And then we build this message. This message is the step before signature, because we have to do the SHA-256. So it's the request timestamp, the request method type, the request path, and then the body that we're passing in, the request body as a string. Yeah, this pretty much builds the signature from all that. I don't know how else to explain it. And then we begin to start adding in our header. So content type, we're passing in an application JSON. Here's the access key, which just pulls it out of the environment variables. Here's the signature, and here's the request timestamp. This is making, okay, that's all resolving itself. Here's it making the actual HTTP call. We then grab the response, so the request body in this case would be a string, or bytes, I guess, and we want to map that into our actual proper body. This returns a string, I believe. No, this returns an array of bytes. And that's what this is. And then what we do is we take that array of bytes and we map it to our response. And the only thing we care about in the response is response.data.address. And so if we look back at our documentation here, it's response, which is then data and the .address. We haven't actually added that to our model, so we can do that now. I'm sure I have here our models. So create address response, it's data, which maps to the data JSON object. And then here is the create address inner response, which is the ID and then the address, the name, all those things. You might as well copy all of this because we're going to be using them all. So and copy the one below. I'll explain all these ones in a second. So we now have a create response, heading back over orders repositories. It does the import. So this method should technically work now. So I'm just going to close it for now since we're not using it. Here are all the imports. Sometimes if you don't have the auto importer, it's hard to guess what they are. And so now our run command, which used to be just go run main.go, I know we haven't actually ran it yet, has changed. It has a few more attributes. So Coinbase account ID, Coinbase API key, Coinbase API secret. Okay, so I realize I have a typo here. Let me just fix that. It's orders repository with an S. This should all be orders repository with an S. So that's our create address. The next one on our list here is for the actual repository file is list transactions. So I'm just going to show you the RESTful call there too. Here's our list address transaction. So this is under addresses and then list transactions. We're going to be using our account ID and the address here. So if you look at the URL, this first attribute is your account ID, and then slash addresses, and then the following thing is your new address. Since technically an address can have thousands of transactions, the whole thing is paginated. So this is how they do pagination. They use URLs or URIs, I guess, and we have to take into account for that. Other than that, it returns a list of data objects. For our process, it's pretty simple though. We just create the address when they go to order, go to checkout. They would submit their transaction, probably in a single transaction, and then we check for that transaction. We get, we're under the limit of 25, therefore we only need one coming back. So we probably won't make multiple calls. It would be pretty low risk if you didn't iterate through all the data objects, but there's always that potential that they send it through in 26 transactions, and suddenly you're missing money and it will never complete. So we have to take into account for that. Next thing we're going to do is just copy this code in. I'm going to walk you through it. Again, I do that so that I don't have to, it doesn't make sense to type all this out when I've already written it all. So the way I handle this is through a recursive approach. We pass in the address ID, so this would be attached to the order. We know what the address ID is. So imagine we're back on our endpoints. Actually, I don't need to imagine. I have my main.go. We have a system that's calling sync order, passing that order ID. Our API is retrieving the order from the database, grabbing the address from that order, and then doing this lookup of transactions, checking all the transactions, seeing if it totals the order price. If it does, you can change the status. If it doesn't, leave it, continue on. If you want to make that even more efficient, you count the number of transactions on your pass run, and then you see if it's changed, and don't bother looping through or something like that. But we don't need efficiency in this case right now. So let's say address transaction here. This would be the address ID we pass in. The reason why it's recursive is for pagination. So we pass in the address ID and the list of address transactions. So as we make more and more calls, we just keep adding to this list. So it starts as an empty list. So here it is. We grab the account ID, same as before, through environment variables. We have the base URL, the request path. Again, same as before, we have it into two attributes. So when we sign, we can sign with the actual request path. This time it's a GET request and not a POST request, so there's no request body. We do the same UTC Unix formatting, we build the same signature, and we set the same headers. We make the request, and now we catch that response. And I see my website has screwed up the formatting here, so let me just fix that. Screwed it up down here too. These were two printouts I was adding when I was just doing some development. So we grab the body, which matches this response. And then we go through each one and we append it to the transactions. In this case, I actually don't even bother handling the pagination. I think I'll probably include that. Yeah, so I mentioned I didn't set it up yet. It's not too hard. If pagination exists and the URI is there, remake the request again with the new URI. But this is it, and then if we just look at the list of transactions, it has the data object, they've enveloped their API calls, and then an address transaction is here. It has an ID, a type, a status, an amount, where the amount is a number and it's currency. So I can better show you an example by just looking at the actual documentation here. So an example of an amount would be, .001, so on, BTC, which is Bitcoin. And so that's the transaction, and that's how we're gonna do this. So that's all the two calls that we need to make. So list transaction and create address. I'm gonna go back to my written tutorial. I'm just trying to follow the flow of it. So two calls go out. The last thing we have to do is actually do the save order, and I'll show you what the order model looks like. So I'm under models and then orders. Here's my order. This is the only actual struct that is purely for this actual project. So let me just change this because this is incorrect. Comma is supposed to go inside the tag. It's just supposed to be a space here. Our order has an ID, which is the document ID. It has an address, which is the Bitcoin address. We have an address name, which is the name that we've assigned. We have a status, which is what the current status of the order is. We have items, which are the items inside the order, so what items did they have in their cart, and then we have the total calculated price. We should create a new method for getting this order from the database, and saving this order, and updating the status. So I guess there's 3 more commands we need to add. So first, I'm just going to copy all 3 of them, and I'll explain them. So I'll go back to my orders repository, paste them here. So here's the first one. This is save order. Our collection is going to be called orders, and pretty much we're going to insert a single order. The BSON tags are the ones that are declaring what the attribute fields are. So we've already declared on the model. We want to return the object ID, the new document ID as a string, and so we just return the new document ID as our order. And as you remember with our handler, so when I say submit order, one of the attributes is order ID, which is a string. It comes from right here. The next one on the list is the order is get. It passes in the order ID as a string. It does a conversion, so it's a primitive object type for the document ID. It then filters by the order ID. It then finds the single one with that, and then maps the order model against that document and returns that order model. The third and final method we're adding here is the update status. It's the only attribute on the order we actually have to change after the order is created. So we pass in a status, which is a string, and we do a set, and we use the ID as the primary key to know which one to change, and we just do an update 1. We'd actually change this to be like that for better formatting. Anyways, so that's the update status. So all 3 of those methods are fairly straightforward, all revolve around that order collection that we're creating. Now it's time to create the service. So we're going to just scroll down. So we've done the order. Now it's time to create the order service. I've included. So the first one is submit order. Simple steps are we want to verify the items in the order. We want to create an address first using the Coinbase API. We want to calculate the price. So we know how to create the order with, total price is this. And then we want to save that order. Then we want to return all our pieces of information. So once again, I'm just going to copy and paste just because it's the easiest thing to do here. So I'm going to services, order services, and paste it. That threw a whole bunch of errors, which is fine because I've, in the written document, also included the imports. Just do that. Sorry, I realized I'm using GoBoilerplate as my name. Oh, I'm using that. Let me just resolve these errors. Okay. What's wrong with this one? Okay. Orders repository does not exist. That's because I changed it to big capital. So let's just go through and fix these. Perfect. Here's the submit order. So we pass in the new order struct. We check to see if items is set to nil or there's no items. If there's no items, we can't create the order. So we just, we return the error order requires at least 1 item. Other than that, we create a new address name. We're going to use a UUID for this. We're going to prefix it with the ID of API dash, so we just know where it's coming from. You can see it on your Coinbase account. We then call our create address repository method that makes the HTTP call it to Coinbase, the Coinbase API. That would return the address or an error. If it's the error, let's return it. I should note, commonly you'd want the error to stop here. You would log the error. So you would log the error here, and then you would return some sort of internal server error or something like that, something very, very general, so that the user doesn't actually know why it failed. You would do so simply because this error is for a developer, not for the user. But since this is a development project right now, we're just going to return the error all the way back up to the REST client. Next on the list, we're going to get the price. So this just involves iterating through all the items, calculating the total price. Fairly simple. I even added a to-do, like you can, if you have a catalog in some sort of in the same database, you can verify each item actually exists so that someone isn't injecting incorrect items or mispriced items or something along those lines. You can also use that as the price and like not accept the price from the order. So you just pass in, commonly you would want to use some sort of variant ID. Lots of businesses have SKUs. You use a variant ID or SKU to do a lookup of the price of the item and then calculate the total price. Yeah, and so next we would just save the order. So add the address, mark the status as the order submitted, save the items, save the total price, and save the address name. Save the order, get the order ID back, and then pass the order ID back through to the handler. It's all fairly simple. The actual business logic is simple now that we have a create address method and we have a save order method. It's pretty simple. Create method, create address, calculate price, save order. Next, we're gonna do the sync order. So I've included the steps here. So it's gonna get the order from the database, which is using the order ID provided in the body. It's gonna fetch a list of all transactions for that address. So it's gonna take the order. It's gonna take a look at what the address is. It's gonna do a lookup against the Coinbase API. It'll calculate the total amount sent, so all the transactions on that actual order. It can be verified to equal or more to the total price. If it's more, it's going to update the status. Otherwise, it's going to leave it. So let's copy that, and then I'll again walk through it. And again, we have the same issue with order repository being lowercase here. Okay, so we first check to see if the body of the order is set. If it's missing, we return the error. We get the order. Again, we get the transactions using the address. With all the transactions, we do calculate the total price. So total expected amount versus total. We do have to do a little bit of a conversion there. And then if the total expected amount, total is less than the total expected amount, we would just return at that point. Otherwise, we update the status to be completed. And that's what brings us into our last method, which is just our get order. I'm just going to copy paste this one again from the written tutorial. A lot of copy and pasting, I understand that. I'm trying to focus on explaining and having this all well planned out, so hence why the copy and pasting. I'm not going to just sit here and type. Get order. We pass in the order ID. This comes from that parameter in the handler method. I can look at that right now. So get order, we grab it from the parameter method, we pass it in. Oh no, I lost my spot. Where's the order service here? We check to see if it's null or empty. If it's an empty string, we say it's missing. We get it from the repository, so that does the lookup on the document ID. So it starts with converting it to be object to ID, and then does the lookup against the document ID, and then returns the order. Fairly straightforward, this method. It's fairly straightforward. All it is returning the whole order object back to the user. Now, if this was for production, I don't know if I would actually return the whole order. What you could be doing here is grabbing the whole order here and then modifying it to build like a more public facing one. So that would be like, in this case, it'd be like the address, I guess, and the address and the well, you already have the order ID because you're making that call. So the total price and the status, those three things. So like you could, created all these things that can remain private. You should probably keep private, but you just add that code just below line 106 there. That's all the code. Let's just start by running it. We don't have an API key, and we don't have a Coinbase account ID or the Coinbase API secret. That is fine for now. I realized I didn't run it ahead of time to confirm that it all worked. no projects. This is Bitcoin. So we're just going to do go run main.go. We can't make any API calls here just because it will actually break. Well, we can against the boilerplate code, but mine compiles. So the nice thing about Go is it would give us a great heads up if something doesn't actually work. Mine works fine. Therefore, I'm going to we're going to begin to set up the actual API keys. All right, let's set up the API key. So you'll need to sign into your Coinbase account. If you look at my screen, I'm currently signed in. One nice thing was when I was actually building this, I created a secondary account to test these two because you can't send Bitcoin back to yourself. So I have 2 accounts using 2 emails. I added $20 to this account, and it's clearly done very well. Under settings, you're going to go to so it's profile settings, and then you're going to be showing your profile, and you're just going to hit API key. API. What you're going to do is you're going to hit new API key. Okay, I'm getting 2-factor off. This is going to be a little bit difficult because I'm just trying to not show too much of my account. So what we want to do is we want to do wallet address create and wallet transactions read. Those are the 2 things we want to do. So scrolling down here, we're going to do wallet address create. I don't suggest doing a select all. Just so all what wallet transactions read, and then wallet addresses create. Notifications URL. It's just a webhook that probably just hits anytime someone starts using it, it hits it, which might be good. Great idea here would be if you have an API set up. I would actually set it up to hit your own API and then go and like hit Slack or hit your email or something like that. But you have to realize every time someone's buying an order, you're going to be getting an email, which is not a problem. But if you start to do really well, it's going to be problematic. I also highly recommend adding a whitelisted IP. If you're in production, you have a static IP address, add it here to avoid allowing all IPs. But since I'm just doing development right now, I'm just going to hit create. Okay, so I see on my screen, and you should too after you hit create, your API key. It's fairly short, I guess, compared to your API secret. You should also see your API secret. Both those values you need to copy down. And what we're going to do is, I'm going to show you my screen again for a second. Right in the root of the project, I'm going to create a new bash file. I'm just going to call it run.sh. Opening up my orders.repository, I just want the exact typing for all my environment variables. Just going to copy this so you have them. You don't need to copy this right this second. Just give me 1 second. I'm just going to do this. I'm going to remove this now. Sorry. And my last. Okay, so with this these are all going to be strings. And I'll show you how to get your account ID as well. These are all going to be strings, and the last thing is it's going to be go run main.go. And we're just going to do an export so these live on multiple lines. We don't have to put them all in a single line. This way, all of our API keys and stuff, you're going to insert them into here. Just only going to show my face, and I'm just going to copy paste my environment variables into here. Okay. And I'm going to close that. Okay, and then again, I'm not showing my screen yet. What you're going to do is at the very top, you're going to go to portfolio. And my API key is gone, so it's no longer my screen, so I can show you my screen again. Okay, so we're looking at my portfolio here. Since we're sending Bitcoin, I want to click my Bitcoin portfolio. This here is my account ID. I don't know if that could be public, but it's going to be public. Why not? Send me Bitcoin if you want. Yeah, this is going to be my account ID, so copy paste that into that same run script. So your run script should be set your account ID variable, so export the account ID. next one should be your API key, next one should be your secret, and the last line should go run main. And so we'll just give that a try. So showing my screen again, we usually just do go run the main, but the environment variables are not set, so now we're instead just going to do bash run.sh, and that should set your environment variables and then start running your endpoints. Again, the only three we care about are these three. So with that, this has all been set. Count ID has been set. Oh, this is the other option for running it. Another one. So it's time to test it. We're going to be making a post request. Oh geez, I have to take a look at the price of Bitcoin. Never thought about dealing with that in this post. I just did a lookup. $5 Canadian is this in Bitcoin, which is shockingly, I think, half the price of what I had here before. It's doubled since I wrote the article, which is good and bad. I'm just gonna add a README here. Is there a README? Delete everything here. I just need a spot to like copy and paste all these commands down. So that's the price I'm gonna charge. I'm gonna use Postman as my request. If you go back to this written tutorial, you can see my request is this. It's to localhost. Here's my items. You put a product name in there. You then submit the actual request. And what I'm going to do is I have two accounts, as mentioned. I was going to build a little tool to help you test this out, but I might have it on the tutorial at the time. First, you have to change the price. That's what I'm going to set my price here to be. I'm also going to create multiple products. So first I'm going to open up Postman, which is a REST client. You can use curl calls, and you can just see what my curl call is going to be. So I'm going to open up Postman. I am going to start my API. Unfortunately, fortunately, I have to have two accounts. You have to test it out with two accounts. So what I'm going to do is on my phone, I'm going to send through from my secondary account to that address. It's going to be kind of painful because of. Well, I'm actually going to use my computer because I think typing out the I can use the QR code. Perfect. So I'm going to use my cell phone to send through to the secondary account. So I'll just send the amount that is indicated in the QR code. I'll send the amount that is indicated I'm setting here, $5 Canadian, to the address that I create. You'll see the new address. I'll show you the new address after I create the order. I'll show you the order in the Mongo compass is what I'm going to use to display the Mongo database. Yes, hopefully that all makes sense. I know I'm kind of speaking out of nowhere here, but opening up Postman, we're going to do exactly what the written tutorial says. We're going to make a post request to this endpoint. Before I actually make the post request, I'm going to open up Compass so you can see. I'm just going to open up Compass. I don't think I actually changed the name of the database. So I'm just going to open up, look here, my main.go for the actual name. It's DemoDB. So I think I'm just going to open up Compass. I'm just going to delete the existing DemoDB. It's from a past tutorial. So I'm going to hit delete here. Just drop it down with DB. And I'm going to drop this other database. Okay. So I'm good to go on my Compass. I have nothing there. APIs running, and then my Postman request. We don't have any authorization, so pretend the person is on your website, they're in the checkout process, and they just kicked off the process. We would then, you would then send a request out with all of their items in the cart. So this would, I'm just gonna go to raw here, and I'm gonna say product 1, and I wrote down the amount I actually want to send through here, which is gonna be this. Let's do this. It seems like less. So let me just confirm this. All right, 250. Yeah, let's do this number then. It didn't actually double. I was wrong with that. Okay, so I'm gonna hit send here. Send. Sweet, order created. So I have an address, which is good because I can tell you that I didn't create that. The order ID is here, and the message is order submitted. Total price matches that. Perfect. Let's use just some confirmation. We're going to take a look at the database with Mongo Compass. I'm on it. Command R, which refreshes the page. I have my new demo DB. I have orders. I have a single order in there. Perfect. I have address name with a unique UUID. I have items. So I have product item 1. I have order, the price of it with the total price. And then we have this address. Status is order submitted. So let's start by, actually the next command is going to be our get order. So I want to just see, in this case, they've now started the checkout process, and now maybe you start by requesting Bitcoin, or they're entering shipping information. So we're going to just pull down the order just to see what we should get this back with the status order submitted. And I'm sure that's my next command here. Oh, I'm sending through Bitcoin right now. Okay, so I don't actually have the command written out there, but it's really not complicated. So I'm just going to copy this endpoint. The request type is get, and then there'll be ID on the end. So I just copy the ID. If you're building a front end, you would take the ID that you get back in response and save it somewhere. Cookies is an easy example, or just like update the URL or something like that. So they're now submitted, and so if I hit get here, this is what I'm looking for. As you can see, it returns a 200 and returns a whole order model object here. And my status is still order submitted. The last command I want to do, and I'm just going to copy paste the same URL one more time, and that order is synced. I'm gonna post. So it's post and sync. And I had copied the request body will be the order ID. I just want to confirm the actual body, like the key. So it's looking for the word ID. So this is gonna be ID, and just so that we send content type and then application JSON, because we're sending through a JSON object. And this will do a sync. This will call that list transactions, and there'll be zip on transactions. But we can do this now, or I'm actually gonna, let me first confirm that on our Coinbase account that we actually have the address created. So heading back over to Coinbase. Under settings here, you can see I have, I'm under settings, so under my profile again, same as API, I go to crypto addresses. You can see that address exists here. You can see the label came through, so you can see this is a newly created address. I wonder what happens if I click, that just copies it. If I hit details, I get that QR code. And this will send money through so I can confirm that the address exists. So I think it's a great time to now do the sync. In this case, it'll be in the background. It does a sync. It says order synced. But the real question is, did the status change? We'll do a refresh. Nope, the order is still submitted. I don't think we have any logs here. So other than calling order synced, we have no logs. Oh, here, transactions came back as empty. So we have no transactions. So the last step here is actually sending through some test funds to confirm that the order it actually works. So I'm just on my phone. I'm just going to open up my secondary account. So I just wish I could record. So what I'm doing is I'm hitting the middle button where it's like the 2 arrows pointing either way, and I'm just saying send to another wallet. And the amount I'm sending, they want in Canadian, eh? Okay, change the currency. What's a Bitcoin? So I have to make sure I select the right currency. So Bitcoin wallet, I have $46 in my Bitcoin wallet. I have the currency as Canadian right now. I'm trying to use the 2 arrows, which changes it to Bitcoin. I have the amount. In this case, it would typically show on your actual website, but I'm just going to type it in from my response here. So I would hate to screw this up. 4 zeros after the decimal. 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. Continue. Not to a friend, not through contacts. There's a little QR button. Coinbase wants to use my camera. Quickly take a. Found it. I have the funds in there. Hit preview send. Oh, that's really unfortunate. Minimum amount you can send is 0.0030 and a 1. Jeez, how much is that? You really don't want me testing this out. 3 and a 1. That's in Canadian dollars. Oh, okay. Let's try this again. Sorry, it didn't work just because I sent too little. Okay, let's try this. 001, and we're going to change the product to be product 2. So we'll hit send again. Brand new order, completely different. In the database, it should say orders, and then yeah, it's a whole different one. Here's my address. I should be able to retrieve that one too. So let me just keep this order ID. So we get that order back. So item 2, a little more expensive. If I do a sync, it should be 0 transactions. So I'll go back to my terminal. 0 transactions, perfect. Let's try to send money through. So to do that, I have to go back to my wallet here and refresh the page. Okay, so this one was created 53 seconds ago, so this is it. So now I have to send through 001. I have to confirm this. I'd hate to really. So 3 zeros and a 1, perfect. Which is the minimum amount. Coinbase, so that's a fair thing to note. You can't send through smaller. Don't sell things that are less than $4.50 Canadian. So 3 zeros and a 1. Hit continue. Not now. 2 and then QR code. Perfect. It's all set up. Coinbase fee is 0. Network fee, there is one. The total cost is $5.25. So $4.14 was the Bitcoin I'm sending through. So I'm just gonna hit send through now. Now this is the thing that got me last time, was the amount of time it took to send the transaction through. So I can say view transaction and the status is pending. Last time it took about 20 minutes, which to me it was too long to actually use. And sorry, I know people are probably gonna comment about this isn't the point of it, and it's a great use for like that's why they have like Bitcoin Cash and things like that for utility things. This is, for me, is entirely experimental, so I just want to see how long it takes through. It will take some time, so I'm just going to start a stopwatch so I can track it, and I'll come back when it's actually gone through. Or I can even just make this sync request and see what I get back first. Oh, perfect. There's the transaction. So let's see if it changed my sync status. Oh, yeah, it's changed to completed. Yeah, see the status is pending, so I don't like that because you should really check to see if the status is complete or whatever. So I'll keep leaving that there as long as the status is pending. Technically, the order actually went to completed because our logic was order service, the sync logic. It grabs a list of transactions, and if the transaction total is more, so what we should really be doing is saying here, if transaction dot status equals, I think it's going to be completed or something like that, but we can wait for the actual order to go through, then count it towards the total transaction amount. If it's pending, it doesn't count. Or if you want to, say like if it's in a pending state, well, it's on its way. Fantastic, like you can accept that as well. So I'm just going to pause here, or I'll cut until that actually comes through as pending. for the most part, that's how this all works. If you have any questions, please put them below. I will continue to update the written tutorial. That's why I have it. Actually, these YouTube videos, you publish them and then you can't change them. So I will keep the written tutorial fairly up to date. Please check back on my website for more updates, and please subscribe to the YouTube channel. Thanks for watching. Okay, so 14 minutes later says it's been confirmed. There's been something like 4 confirmations on my transaction. Let me just run this one more time to sync again, just so I can confirm I can see the transaction myself. So in my log output here, I have completed. So again, if you actually want to do this so that it only accepted the payment once it's actually been completed and confirmed, you would do transaction.status equals completed, and then it would count towards the total. Yeah, 14 minutes. I actually kind of walked away, and so it could have been a few more minutes earlier than that, but that's fine. Once again, hopefully you like this video. It's all, it was all kind of exploratory for me. I can't say I, interact with Bitcoin at all. So as a developer, I just want to understand it. Thanks for watching, and so please subscribe.